All right, so now we are going to discuss compound operators, which you have already seen previously. So compound operators provide a shorthand way to update a variable. For example, addition assignment, so age plus equal 1 is equivalent to age equal age plus 1, which means like incrementing the value of age by 1 and then assigning it to the same variable named age. Similarly, subtraction, subtracting the value of age by 1 and assigning it to the same variable. Similarly, we can do it for the multiplication, division, and modulo operator. So now let's talk about what is actually division and modulo. So we know that the division operator is is performs the division and returns a floating point number value. So when you divide 20 by 10, it returns a value of a type decimal, which is a floating point type 2.0. So here again, 50 divided by 50, although it is an exact integer value, but it still returns the value in the form of a floating point data. Okay, 5 divided by 10 is 0.5. Now here, another type of division operator that we have is called the floor division operator that has two forward slashes in order to, and we can use it in order to round down the result of a floating point division. Okay, so the result is an integer type if both operands are integer, and if either operand is float, then the float is returned. Let's take an example here. So 20 floor divided by 10 would return 2 because both the operands are integer. Here again, 5 floor division by 10. Since the result is 0.5 and it actually drops it rounded down. It drops the decimal part. So remainder 5 is thrown away. Here 5.0 is a floating point value. When it is divided by 2, it returns, if we simply divide it by 2, it would return 2.5. But since we are doing it in a floor division, so it actually drops the decimal part and throw off the 0.5 value and it returns the floating point 2.0. Okay, so this is what we call the floor division. Next, we have the modulo operator. It evaluates the remainder of the division of two integer operands. So for example, 24, if we have to divide 24 by 10, so the remainder that we get is 4. So if we have to receive the remainder only, we use this percentage operator, which refers to modulo operation, or short for mod operation. So 50 by 50, there is no remainder left, so it would return 0. Here 1 by 2, so it cannot be divided. Actually, the remainder is still 1, so it would return 1. Okay. Now, if we have been given a number, we can use modulo operator and floor division to extract each digit from the number. So example, for a 3-digit number like, let's say user underscore value is 927. Okay, so if we have to extract the last digit, so how can we extract it? So let's take it on the whiteboard. Okay, so if we have 9, sorry, let's do this here. If we have 927, and let's say in our program, we are receiving a string of numbers in which we have to extract, let's say, sorry, let's say this 7. So how can we do that? So we know that the remainder operation returns the remainder value. So if I were to divide 927 by 10, so if I divide 927 by 10, I can actually do it with 92 times 10 would return 9200, and what is left is 7. So when I perform this operation with 10, it would return me the value 7. Okay, so if you have to extract the last digit, you have to divide it by a number 10 containing 1 0. If you have to extract last 2 digits, you have to divide it by 100. So when you divide it by 927. If you divide it by, sorry, take a modulo by 100, it would return a value 27. Okay, so this is how we can extract the last two digits by using a modulo operator. Similarly, if we have to extract the first digits, for example, well, let's do it separately, 927. And if you have to extract the first digit, we can simply use the floor division operator. The floor division by what? Since we have to escape two digits, two lower digits, we have to divide it by 100. So when we divide it by 100, actually floor division, so normal division would give me result if I were doing a normal division, it would give me 9.27, right? So if I do it with the floor division, 127, it would give me a value of 9, which means the first digit I get. So if I have a long number, let's say 2, 1, 2, 0, 1, 2, 3, 4, and if I have to get first three digits, what do? I would just divide it, oh sorry, floor divided by something which has three zeros and 1, 1, 0, 0, 0. When I floor divided by 1000, I would get the value 201. Okay, so this is how it is. Let's go back and see we have an activity coming up. So this is the same example that I have just explained to you, maybe different in a different way, but the idea is same. Okay, so what we can do is, so this is an activity number 3. So suppose that a phone number, if you call a Stanford welcome desk, is 203-251-8400. So extract the prefix value 251 and store it in a variable named number underscore prefix. Okay. And suppose you have a number, the phone number is stored in this one, and we have to extract the value 251 by, I mean, sorry, we just have to extract this 251, okay, and store it in another variable named number underscore prefix. Okay, so try doing it yourself. Otherwise, I have a solution already prepared. So give it a pause and proceed ahead once you have the solution ready. Otherwise, I'm just proceeding ahead. All right, so what you can do is, as I said, in order to extract the last piece of digits, what we can do is we can actually take a modulo, or if you have to extract the first number of digits, we have to divide we have to take a floor division a by a specific number of digits that we want to escape. So here, let's assume that we are extracting this first part first. So the first part first, eliminating the last four zeros. So we have to take a floor division by something which has four zeros, okay, which is 10,000. So when we divide it by 10,000, we get these first six digits. And in order to extract the last three digits from these upper six digits, we can simply take a modulo by 1000. Okay. So dividing it by 10,000 will give us 23251, 203,251. And here 203,251 is then further processed with the help of a modulo. And we took a modulo by 1000, which returns us 251. So this is a common problem. So just assume that you are receiving a runtime data, or for example, you have received a string of data, or maybe let's say you're processing some digital data, and the digital data is always in the form of, let's say, always in the form of ones and zeros. But in the data packet that you have received, it could be a SMS, it could be any kind of data that you have received. So that digital data, so let's say, let me pull up the board again. So suppose there is a transmitter source, let's say TX, which is sending a data on the receiving end, RX, and that data may contain 10111. 1 0 0 0 1 0 1 and all that. Okay, but the receiving end knows that it has some information enclosed in it, and the required information that we're looking for is somewhere in between here. Bit number, let's say, starting from left to right, bit number 4 to bit number 5, 6, 7, 8, 9, 10, bit number 10. We have to extract these bits. So we can apply similar kind of technique that we have just learned to extract these bits and then decode this data to something meaningful. Okay, so this is one of the such a simple example of how we can actually employ this technique to solve our problems. Okay, so let's talk about this module in a separate video.